Alright, circles again, right? So we're going to do something a little bit different than what we've been doing today. Let's talk about a word that we actually talked when we started doing that trig stuff. Let's go a different color here. I don't know, let's go red. Red's not very red on this, but red for red lion. Okay, here we go. Watch this. I'm going to draw a line. Are we listening? I'm going to draw a line. It's not going to go through it. It's not going to completely miss it. What's my other option? Okay, it's going to right about right there. Okay? So it actually touches the circle. Now, how many points do you think it touches the circle? Just at one point. Okay? Just at one point right there. Right? When we have this is considered a line. When we have this line right here and it touches the circle just at one point, right? It doesn't go through the circle. It's not like this. It's not like it's going and stopping. Because if it went and stopped, remember this is a line, what would it eventually be doing? It's an arrow, so it means it would keep going, wouldn't it? So this would actually, this would actually hit the circle at 2 points, wouldn't it? But this one right here doesn't. It only hits the circle at 1 point right there. Yes?
What would happen if, like, it was in the circle, but it was a ray, so it only touched the circle?
Then it's not a line. These are lines. Okay, these are lines. So it's not a ray. It's a line that keeps on going in both directions. So the only way that it can touch the circle, or it can hit the circle at 1 point, is if it looks something like this, right? And we call that line right there, we call it a tangent. You ever hear anybody, I do this a lot, if you haven't noticed. My conversations, they start in a certain direction, and then they just go, they go off on a tangent. You ever hear that expression? Somebody say that? That's kind of like my stories sometimes. They just go off who knows where, right? So the circle should have, or my story should have stayed within that circle, but what does my story do? It just goes, whoop, takes off, and it goes way crazy, all right? Not all the time, but sometimes it does. So that's I guess that's where they got the expression, you know, don't go off on a tangent, or, man, their story went off on a tangent. You know, if you hear that, you don't hear it that often, but every once in a while you do. So whenever I hear it, I'm thinking, tangent, circle. Your line hits the circle at 1 point. I don't know. That's me. All right, so maybe you will think of the same way. Look at this point right here. This is the point where it's the only point they have in common, that the circle and the tangent line actually have in common. And we call this point right there the point of tangency. The point of tangency. All right? We're going to use that expression quite a bit. All right? So make sure that you understand what that is. It's the point where the line hits that circle. Only hits it at 1 point, not at 2 points, just at 1 point. Everybody got that? It's just vocab right now, isn't it? Haven't really said anything about it or what equals what or anything like that. It's just vocabulary. Any questions so far? Pretty simple stuff, isn't it? Let's do this. Put a couple circles here. Put one here, make one just a little bit bigger, about like that. We're going to talk about a thing called common tangents. So if it's a common tangent, then it's going to hit both of these circles at 1 point. It's not that easy sometimes to bring that here, bring that up a little bit, change the color of it, go to this nice blue. There we go. That's pretty close. So look, that line right there hits that circle. We'll say it hits, okay? We'll say it hits right there on that circle, and this line hits this circle right there. All right, so it's tangent to both of these circles. You follow me? So we call that a common tangent. So these circles have a common tangent, which means they have a tangent that's in common with both of them, right? It's tangent to this circle, and it's also tangent to this circle. So we call them common tangents. That's pretty easy to understand, don't you think? How many common tangents are there with two circles? Think about it. Is that the only common tangent?
There's one on the bottom.
Okay, yeah, one on the bottom. Okay, so about, oops. Got right there. Let's, that wasn't very good, was it? Oh my goodness, what am I doing? Let's try this again. What should I hit, that middle one? How do I do this? Oh, drop it down like that. That's what I want. And then take... Is it good enough? Not quite.
It's good. It's good enough.
But lifting that one, how did I do this? I don't want to rotate. Let's do this.
There you go.
Boom. And then rotate this one up a little. And then we'll just move the whole thing up a little bit, huh? Sorry. I know. Alright, there we go. Close enough. But I don't know. I just can't. I can't stand it if it doesn't look right. Okay, so there we go. There's another common tangent. Alright, we good on that? So only two common tangents then?
Yeah.
Right, you got it. Okay, so let's. Yeah, you think that was hard? Watch this. So it'll probably go about like that. Right, and then that was kind of close. I wish I could just grab one end and just kind of scooch it down without moving the other one. That's good enough. Alright, so watch. So it hits right here, and pretend it just hits at one point on that circle right there. So that would be another common tangent, wouldn't it? Alright, and where do you think the other one is? Just going the other way, right? And let's see if I can do this any better. About right there. Yeah, so there's 4 of them. That was way off. Can't be perfect? Why not? That's true. Ah, that's pretty good right there. So watch. Right there. Right there. It hits. So look, how many common tangents do we have between 2 circles? 4 of them. And so you got 2 that go inside and 2 that go outside. So the ones that go outside, I would call them what kind of tangents? Exterior. Good. Exterior common tangents. And then the one that go inside, interior common tangents. Okay? Make sense? Alright, enough of that. That took too long just for that little silly thing. We could also... what do I want to do here? Okay, let's do this. We could also say that circles can be tangent to each other. Let's make this one a little bit bigger. So, yeah, if they're now when you say touching, what does that mean? Look, they touch right there. Are they tangent to each other? They touch here and they touch here, right? But they only touch at what? At one point.
Like a binocular.
Okay, so they only touch at one point, or a sideways snowman. Okay, let's make it look like a snowman. Right there. Okay. And then there we go, snowman. Yes. Thanks, Alyssa. Thanks for paying attention. All right, so look. So right here, these 2 circles right here, they touch each other at one point. So we say those circles. Listen to me. We say those circles are tangent to each other because the 2 circles touch each other just at that one point. There's another way I could make these tangent to each other. Did you know that?
Yeah. What about the inside?
Yeah, this could be inside, couldn't it? Now, what if I had it right there? Nah, that's not because it doesn't touch the other circle. Now, they do share the same center. So what is it, Alex? Say it again. Cohen? It's not Cohen. It's close. It's very close. Concentric. Okay? It's concentric. We say concentric circles. But that's not what we're talking about. We talked about the other day because they don't touch each other. Watch. What if I move this? Boom. Right there. Alright? Alright, and it touches right here.
It's an aerial view of the snowman.
Alright? Is that what it is?
Yeah.
Okay. Alright, so so there you go. So look, they touch right there. They would be tangent to each other as well. All right. And a little bit later, not today, but in another lesson, we will talk about circles that are tangent to each other, like that. Okay. And there we go. How many common tangents would these 2 circles have?
1. No. 3.
Okay, there's 1, right? Oh, I'm terrible at this. Watch this. See, I'm learning. Okay, so that's 1, right? It hits here and it hits here. Let's go green. Okay, and then and then just see, now I'm getting, that's close. right, so we'll just say that. All right, so that's another tangent. Where's the third one? Right through them, right? Because remember, it only hits at one point right here, doesn't it? So I would say about there. Now, technically, it looks like it hits at a whole bunch of points in here, doesn't it? But remember, these lines have thickness, they have width to them, but a real circle and a real line doesn't have any dimensions to it at all. It doesn't have any thickness to it. It doesn't have any width or height or depth or anything, okay? So really, they actually do hit. Even though if you look at this, they're like, look, it's hitting from here all the way to here. That's not just one point. But you got to consider the tools that we use. These just represent lines and they represent circles. It's not an actual line and an actual circle, okay? Does that make sense? Yes.
Does that line, the yellow one going through it, does it have like this one point that both of them share?
That's what I was just talking about. Yeah, that's what I was just having a big talk about. Was it doesn't share a whole bunch of them, it just shares one point right there. Okay, that's in common. All right? So those are common tangents. We good with that? All right, that was pretty easy. All right, enough vocab stuff. Wow.
You're squeezing him together.
Knocked him over. He's on his side, and she said I cut his head off.
And you're squeezing him together.
And so his head would roll down the... That'd be cool if I could animate it, right? And have it doom, 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 roll it down like this. Okay. All right. We see a different side of Rachel. Chopping snowman heads off. All right, here we go. You ready? Let's do an example where we actually use some of this stuff. Actually, I lied. Let's do another theorem, because right now all we learned, we haven't learned any theorems at all. We haven't learned that anything's equal to anything or anything's whatever. We haven't learned anything so far. Just vocab. So what I'm going to do, let's draw that. And let's just change colors of this. Guys, pay attention. Just because I'm drawing stuff up here doesn't mean you can do and say whatever you want. Let's pay attention here while I'm drawing these things out. Okay, here we have a situation where we have a line. Listen to me, please. We don't need to comment everything. I get it. Okay, Jersey Shore, this situation, I get it. Okay, just because I say that, think it to yourself. You can think it to yourself. But you don't have to say it out loud, do you? Talking to you and you. Neither one of you looking at me. That means you know that I'm talking to you. Look at this. Just pay attention to me. If I had a line that connects from the center of the circle to this point right here. Now, we look at it two different ways. If I told you that these two colors look exactly the same. Let me change one up. Yeah. All right, look. This green one right here to this purple one, if I told you that it was perpendicular, then you could say that this purple one right here was a tangent. So we have a theorem that goes two ways. We said if the radius is perpendicular to, how do they say that? Let's see, if a line is tangent to a circle, if and only if it's perpendicular to the radius drawn to the point of tangency. Not sure how to word this. But anyway, let's just make it as easy as we can. If this thing is perpendicular to this one right here, and it only hits a circle at one point, I know that is perpendicular, the radius is perpendicular to the tangent. So, so I know that that's a tangent line. I didn't say that very well, but it's in the book. It says in a plane, it says if a line is tangent to a circle. So if this line is tangent to a circle, okay, if and only if it's perpendicular to the radius. So if this is a tangent, then it must be perpendicular to the radius. You're like, well, is that the only tangent that I could draw? No, I could draw a tangent like this, couldn't I? So if I drew the radius to this point of tangency, tell me something about the radius and that point of tangent at that point right there. Well, it must be true. It must be perpendicular. Everybody see that? So if I draw a tangent line to a circle, and then I connect the radius, right, the center, to that point of tangency, it's going to be perpendicular. Make sense? If it's not, then that's not a tangent. You got it? And if it's not a tangent, then it's not going to be perpendicular. Got it? Okay. So that's what our theorem says. That's theorem 1010. I don't really care about the name of the theorem. Let's do this, though. Let's do an example using that theorem. It's really not that hard. The longest part about this is just drawing the thing. So let's draw a tangent.
I like that you're writing it that you have black triangle.
Okay. Actually, I'm gonna do this. I'm gonna take that tangent and I'm just gonna take it to the point of tangency. Is that all right? Now, technically, it is a line that keeps on going, but I'm just gonna stop it right here. Okay, we're not gonna consider the rest of it. We're just gonna consider that part right there. Everybody got that? Now, if I was to, now that is right there. What is that? That's the point of what? Tangency. So if I was to connect the radius to that point, what kind of an angle do we have? Right. Okay. But let's do this. All right. Now they give you some values here. They tell you that this is 15, right? From here to here is 15. They tell you this is 8. Now, it's not really drawn to scale because the 15 and the 8 almost look exactly the same, don't they? And they tell you this is 9. Now, when they put a little 9 right there, they didn't have to say exactly what it is. It's just from point to point. So where do you think it is? It's from here to the circle. That's right. So that 9 only includes that bit right there. It's not the whole entire thing. If they wanted to tell you the whole entire thing and it went through this point, they'd probably do that little curvy thing that I do, or put a couple lines here and put the 9 in between them. Does that make sense? Right, but if they just put a 9 sitting out here, it looks like it's just floating around in the middle of nothing. It's between here and here. And the question says to find, to determine if this is actually tangent to the radius. So how do we know if it's tangent to the radius? Well, we know it's tangent to the radius if what? If this is a right angle. How in the world can I determine if that's a right angle? Do I just look at it and say, sure, it looks like a right angle? Is that what I want to do? What do you think, Alyssa?
Don't you have to do the Pythagorean Theorem if it works?
Yeah, if it works, right. So take c squared and compare it to what? A squared plus b squared. If it's equal, if c squared equals this, then yes, this is a right triangle. That means that's a right angle. That means that this is a tangent line. You got it? So what's the c?
9 plus x squared.
Is it x? Is this an x?
Yeah.
From here to here? How do you know it's 8? It's the radius of the circle. That's right.
Sheesh!
Okay, look. From here to here is the radius, isn't it? And so from here to here is also the radius. So that has to be 8. You got it? So what's the whole thing? 17. Okay? Now, if you wanted to, now watch. Here's another thing that we learned before. Are you watching? Here's another thing. Look at my sides. I got 8, I got 15, and I got 17. Does that ring a bell at all to you?
Ding ding ding.
It's a special right triangle. Yeah, it is. It's a Pythagorean triple. Remember, what's the easiest Pythagorean triple?
3, 4,
3, 4, 5.
3, 4, 5. Right. 3, 4, 5 is one. This is another one. 8, 15, 17. Okay. 8, 15, 17 is a Pythagorean triple. Why are you looking confused?
It's in like chapter 4.
I've never even heard of that in my life.
Yes, you have. You were here for it, but you may have not remembered it. We'll put it that way. If you really wanted to, you could do Pythagorean Theorem and figure it out, right? So let's do it real quick. 17 squared, compare it to what? 8 squared plus 15 squared. And let's see what we get. 17 squared, is that 289? 17 squared. Yep, it's 289. Oops, that's ugly too. What's that? 64 and 225, is that right? What is that? 289. How about that? What do? They equal each other. So guess what? What kind of triangle is this? It's a right triangle. So that means that's a right angle, which means what is true about this thing right here? What is that? It's tangent to the circle at this point, correct? All right, so that's all they wanted you to do. They wanted you to show that this was actually tangent to this circle.
So how do you write it out?
Just what I did.
So that's all you have to do is
Yeah, 289 equals 289, so that's right, and so yes, it's tangent. Write all this stuff. Draw the picture, write the 17. Yeah, write 8, 15, 17 triangle. I don't know. Why are we trying to get out of doing work? Just show your work.
Because if you could do that, then
Alright, let's keep going. Let's see what else do we want to do. We do this one. This is the last one. This kind of leads you up to the next. In the next section, we're going to be doing more stuff with tangents, all right? And it's going to get a little. And the section after that as well, we're going to do more tangents. So this is kind of like I told my other class. This kind of splits the chapter in half. It's like all the stuff we did before this kind of go together, and then all the stuff from here to the end kind of go together. That's right. So there we go. So watch this. What if I had a point? Let's change colors. Will this dark blue show up? Not too well, huh? Let's change it to that nice light blue. That light blue looks good. Okay. So here's a point out here. What if I wanted to do this? What if I wanted to start at this point outside the circle, and I wanted to draw a tangent to the circle? All right. I wouldn't go like that, would I? What would I do? Till right there, right? But I want to stop right at that point of tangency. Is that all right? So I'm going to take this right there. So that's tangent, all right? But I'm stopping at the point of tangency. Got it? Let's do that again. Let's start from that same point, and let's go tangent. We can get two tangents, can't we? Out of this from that point outside the circle. But I'm not going to go all the way through. What do I want to do? I want to take it all the way to that point of tangency. So we'll stop right. As soon as we hit the circle, we're going to stop. So actually, I've made a line segment, haven't I? I've got this line segment here and this line segment here. Off the top of your head, what do you think might be true about those two blue line segments? They are equal to each other, congruent to each other. So I'll put a little tick mark here, a little tick mark here. They are equal to each other. Exactly right. All right. Now, they could do a lot of different things, I guess, but here's something really simple. It's not that hard. What if they said that that length right there was 2x plus 9, and this one was 3x plus 6? Could you find the lengths of those two segments? Yeah, so let's do it real quick. So what do you do with those two things? Yeah, we've been doing that all year. This is really simple. Subtract 2x, that's an x. Subtract a 6, that's a 3. So what is this? 2 times 3 is 6 plus 9 is 15. So this should be the same thing, right?
Yeah.
Let's just double check, see if it is. Put a 3 in there. That's 9 plus 6 is, 15. So there you go. Easy, isn't it? Okay. We're going to be doing a lot more stuff with a point outside the circle and tangents drawn to the circle. This is just kind of like a little introductory thing for you to get you going on this. All right. I think we covered everything.
Homework.
Yep. Yep, that's it. Let me give you some work to do. Let's see. Here we go. So it's section 10.5. You guys paying attention? Write this down now while I'm writing it down. Alyssa, pay attention to me. Pages 722, 723, and 13 to 27. It's 15 problems. What's that? I think these are easy. This is almost like the first lesson of a chapter. You know how that's usually kind of easy? Because remember I said it kind of splits it up into two halves. This is kind of like the easy part. It'll get a little harder the next lesson, the one after that. But this should be pretty simple for you. All right, that's it. Have a good weekend. Go to the play tonight and this weekend. Okay.
I went last night.